All right, well, I want to welcome everyone to Heat Pumps and Gas, Cold Climate Hybrid Systems. Hey, they're here. And so this course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator for this session. My name is Brett Little, and I am the program manager here. As always, these courses are approved for multiple different types of continuing education units, as well as our own internal certified green home professional under the health and energy pillar, as well as AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Real excited about another new membership alert. We talked to you a little bit about this, where if you are a member, you're going to get access to that Green Builder magazine, a real hard copy, believe it or not. They have a virtual one anyone can get, but you can get a hard copy. So make sure you're signed up for that. And then also next week, we've got the one and only Sam Rashkin hanging out with us, talking about the next generation of housing 2.0. It's a webinar. You'll get instant access to that if you're a member. And they have a 6-part series coming up starting in May about Housing 2.0, and you get completely free access to that as a GHI member. So get signed up. We've got a couple of these mugs left from our board member at True Tech Tools, Bill Spone, who sponsored them. Corn-based, made in the USA. We'll send it to you. We're almost out. So once you sign up, we'll send that mug your way. And before we get started, I want to say a huge thanks to our top tier sponsor, Mitsubishi. Mitsubishi has all sorts of systems that you can use to help with all electric air source heat pumps that can be ducted. They can be partially ducted, semi-ducted, hidden so you don't see the mini splits if you're concerned about those visual looks. You know, take it from me. I live in a cold weather climate. It gets really cold here. We swapped out the gas furnace, put in a ducted air source heat pump system with their technology, and it works just well. I've made it through this winter. I'm alive, and I was very comfortable. So check them out. They've got the traditional mini splits, super energy efficient for your buildings. We're still seeing a lot of those get installed as well. And again, the hidden cassettes, many different ways those can be hidden in the ceiling, on the walls, so you don't have to see those mini splits sticking out if you're concerned about that. They've got the dry mode, so you can set your system up, and when cooling isn't quite happening as much, it can help to remove that excess humidity kind of into those swing seasons that we're coming into. And make sure that you've got a diamond contractor that you're hiring or getting certified, getting approved as a diamond contractor. And they've got it under Ductless Pros and all sorts of different professionals. So you can check those out on their website as well. So just make sure you head over to MitsubishiElectric.com. You can check them out and learn all about what they have. We also want to thank our second tier sponsor, Ava Window. They've got windows all the way up to R7 as far as resistance to heat. And one cool thing is they've got recycled aluminum windows as well. You can help reduce embodied energy using recycled content on your projects as well. So check them out over at avawindow.com. So again, I am really excited about this topic. You all heard me probably back at the Residential Net Zero Energy Conference a few weeks ago, talking about, what we need to do. And so we need, if you remember, we need weatherization to help ensure electrification. And then we only need a little bit of solarization, and then we can get to decarbonization across our nation. And for those of you outside of the US, Canada, Europe, we want everybody decarbonizing. Europe, especially now, you all have to move forward rapidly on that for all sorts of various reasons. And so, one thing that's concerning, of course, with weatherization is we want to do it. We need to do it. It's very important. It can be very expensive. A lot of people aren't offering that service anymore. The utilities are throttling back the incentives that are available for weatherization. And there's a lot of liability that comes with weatherization. If it's done wrong, it can cause health issues and moisture issues. So we definitely encourage it. It's got to be the first thing you do, but there are a lot of things that get in the way. And so that can make the electrification piece that we all have to rapidly do become very, very challenging to ensure that we get enough BTUs out of systems, especially in cold climates like where I'm at, where it can be difficult. And so the other issue we have to contend with is the fact that we have a lot of grid systems that are still heavily coal-based. They're still high on carbon emissions if we try to electrify our heating and cooling systems. And they have high cost versus really relatively low gas prices. And so from our perspective, we do a lot of work in the green affordable housing sector. It's unequitable and not fair for those in low income situations or communities of color not to be able to access this new technology. They don't always have access to it. But even when they do, and there's funding available for it, the other problem you have to contend with is the higher electric bills that they might have to take on. And we can't place that burden on them either. And so, and even just anybody normal, that could increase your costs, especially in those areas with high carbon emissions and high electric costs. So these are concerns that we have, and we want to figure out what we can do about it. And so we're not solving the problem here today, but we think that we've got something that generates a new way of thinking about this, a new conversation, and we want to make sure we have it. So we've got some fantastic guests. We're first going to hear from Chad Gillespie from Mitsubishi talking about technology that's coming up that's going to be able to help solve these issues. And then we're going to hear from Diana Kako with Slipstream, who's going to talk about a study that they did on some of these types of systems and some new things that are coming up. And then finally, we're going to hand it off to my former friend and colleague, or friend and former colleague, Jason LaFleur with Gas Technology Institute, who's going to be talking about some of the future and some of the direction we need to head with these types of systems. So with that, Chad, I am going to turn it over to you, and please do take it away. Welcome.
Yep, all right,
great. See it. Thank you.
Awesome. Thank you, Brett. And hello to everyone. I figured that this might be a good time to just give a few slides on kind of the market itself. I am from Mitsubishi Electric, and we have been here for over 30 years selling high performance heat pumps, and a big advocate for moving to a more decarbonized grid and electrification in general. And, we're seeing a lot of things happen within the market that are concerning. And, this is an article from yesterday just showing the prices of natural gas. And, we see this all-time high, or this high since 2008. And then other factors are not even contributing to that, which could be a concern as far as the war in Ukraine. There are lots of things that we really are concerned about. And I believe that if we can shift some of this to more electric, a smarter grid, we will have a more resilient grid and more energy independence. But it was just interesting because it just came up yesterday. But as we're looking, make sure that, here we go, at where fuels are today, we certainly are seeing renewables are really moving forward rather rapidly, and that's always a good thing. And we get the question is, as far as how can we handle this, all of this new electric need that may come from moving towards heat pumps, electric vehicles. The grid is pretty amazing, and we've done a great job since 1960, improving the grid and growing the grid quite rapidly. So it's certainly not without a possibility that we could grow this again to incorporate a renewable grid that could support all the electric movement that we're seeing. This is a grid real quick on for Princeton, a study they did on where renewables would probably be most successful. And as you see through a lot of the states that Brett and his team cover, there's a lot of wind power there. So this has really helped support as we move to a less carbon intensive energy production, reducing coal and using natural gas to segue through until we get a renewable grid. But there's a lot of different factors that are really moving towards promoting or supporting electrification. So with this presentation, we are discussing dual fuel systems, and what we're talking mostly about today are variable speed systems, primarily with our systems with Mitsubishi, and there are several other manufacturers out there. We have an 8-coil system, but I wanted to show where traditional dual fuel systems that we've had around for years, kind of the difference here. And this is from one of the leading manufacturers' websites. And why I took a snapshot of this is it really shows you that, they have systems, and they promote it as to use it in for mild climates. You would use your heat pump, but not in cold. So they're looking at about 40 degrees and above to use the heat pump for heating, as well as in the air conditioning when it's hot. What we're looking at with the systems like that we have with variable speed, we have 100% capacity down to 5 degrees or 0 degrees, with the ability to heat down to the negative teens. So, and again, there are other manufacturers that can produce this or similar type systems, but again, this is more of what we want to talk about. And if we look at an example here of where the switchover temperature is, and the switchover temperature is where we move from utilizing a heat pump in heating mode to using another source like natural gas for heating. If you look at the switchover temperature, we would go much below 40 degrees. And we are extremely efficient if you look at 10 degrees, we're covering the majority of the heating throughout the year with only electricity. And this is critical as we see moving forward to reaching electrification goals and decarbonization goals that we have. So the system here is not what we're seeing as your traditional dual fuel, that it heats down to 40 degrees and then your gas furnace picks up the majority of your cold temperatures. So what we're looking at here is to really expand this market, not only for new construction, but also for retrofits. And so when we see in this diagram down to the left, you have your blower fan at the bottom, you have your gas furnace in the middle, and then on top of that is generally an air conditioning coil. With our system, or a system like ours, what that would be instead is a heat pump coil, which we call the A coil. It can do both your high performance air conditioning, but also your high performance heating. And again, it will operate majority through the year and then only rely on the gas furnace for very cold conditions. So when we look at this, we've asked, does it make sense on an old furnace? Now, maybe not on a furnace that is 25 years old, but if a furnace is there and the air conditioning coil it generally goes first before the furnace does, it does make sense to make this change, to leave the furnace in place if you were in a very cold climate and is fully functioning, that you could then move over to using a variable speed A coil system to then replace that aging A coil. So then you would have the benefits of still having your furnace in very cold temperatures. But again, for the majority of the year, you would have this high performance heat pump, and that would produce heat and then air conditioning in the summer. And we still get this question a lot as far as how it works in the winter. It still is a high performance system that is able to extract heat even when it's very cold outside, and through the refrigeration cycle produce heat inside. And with that, we still see very high indoor temperatures coming out of our heat pumps. The old heat pumps that probably a lot of our parents or some of us may have been used to, those discharge temperatures were not very hot. So if you have a discharge temperature that's still 96 degrees, that's still below our body temperature. So it's not going to feel warm. So we can see heat pump temperatures, 135 degrees discharge, which is very warm. And again, as Brett said earlier, he did survive a winter very comfortably, and we're happy about that. We have lots of projects throughout the Northeast and the Central North that have been very effective using our heat pumps. So with this kind of system, each manufacturer, is only a couple of us that have an A coil type system. With ours, it could pretty much be used with any furnace. It has variable sizes of it physically, as well as the tonnage it can produce. So here what you see is the outdoor unit, and it basically is a refrigeration cycle that communicates with the indoor unit A coil, but also exchanges refrigerant, allowing it to cool and heat. And it sits on top of that furnace. So in this situation, we have what we call a 1-to-1 system, which is one indoor unit, one outdoor unit. But if you wanted to go into a multi-zone configuration, you could have something like we see here, where the outdoor unit not only handles the indoor A coil, but if you had another air handler like a wall hung that's displayed here, you could do all of that with one outdoor unit. So very flexible on what we can do moving forward. So not just for retrofits, but certainly for a lot of higher performing new construction homes, this is a great option. We have seen our houses that we worked with our builders in the Northeast and the Central North, where they're in very cold climates and they got through the polar vortex with no backup heat. So again, those are highly insulated, very high performance homes. But again, moving forward, we can see a lot of applications for this in the new construction market, but also the retrofit market for sure. And again, this is for your installers. This is not going to be terribly difficult for them to install. If they've done mini splits before, then they should be completely fine with a couple hour training that we offer to get them up to speed on integrating the new A coil. There will be a lot of training as we release this in the next few months on this product. Ours is coming out very soon. We were hoping for it to come out a few months ago, but we wanted to make sure that we had all the pieces in place, all the training ready to go. But again, very simple. If we're looking here about how they're compatible, how they're hooked up with thermostats, very similar to what HVAC contractors have done in the past. So there's not a huge curve for them as far as learning how to utilize this technology. And again, with the size and the capacities, you can see here, it can be used in multiple configurations, vertical or horizontal. And again, with the sizes you see here, the capacities, you've got lots of options. So again, what we can do is with your contractor, better understand where you are today with your home or the home you're building or retrofitting to understand what type of capacity you may need, and then what type of capacity you'll allow to be in those really cold days. So we have those options. It will be a design understanding in the beginning to really get the contractor to understand how much they're going to utilize with the A coil for heating versus what they utilize for the gas furnace for heating. A few things here. What we're seeing on efficiencies, you can see here, still very efficient. One thing that I'll mention on the SEER, if you look at ours at 17 SEER or even Daikin's at 14 SEER, Bosch is 16. The way AHR rates these systems, they actually kind of give you a penalty because they basically make you take in consideration things that your system may not have as far as blower size and wattage consumption. So here is 17 SEER. That's probably a little under probably what it will end up being. Most of our systems and ducteds can easily hit that 17 or higher mark, but you still are seeing some really good heating efficiencies. But again, really, if we're looking at this to displace natural gas, it's a great option as far as efficiency goes. And again, you also get the benefit of a higher performing air conditioning system. This is kind of a comparison of what some of the systems that are out there today, where they are as far as efficiency. Can they connect to any type of furnace or not? Just some of the options we have here. If they're like for our system, you'll see that is a 100% capacity down to 5 degrees. That is not always going to be an option for some of the other traditional manufacturers. So if you look at, say, Carriers or Trains or any of the major manufacturers of the traditional dual fuels, you are not getting that variable speed capacity compressor system that allows us to get down to that really, really low temperature heating that we get at 5 degrees or negative 13 degrees. So this kind of gives you an idea of what's out there. But again, there are other systems besides Mitsubishi, but right now we feel like we've put together a really fantastic system here to go with the existing furnaces in a lot of homes. So the way the switchover tool works, and I would not even begin to explain this because I couldn't do it any justice as far as our engineers our product people, and even in Mark Knudsen, who's on the phone here with us. What I can tell you is this allows us to look at the variables of the house, the cost of electricity, the cost of natural gas, to really dial in the best performance for the consumer. So we always want them to be comfortable. So there's two different ways to look at how we do this switchover. And the big thing is that, again, keep people comfortable, but also trying to reduce as much natural gas without causing a major cost in heating for the consumer. So this will allow us to input these different data points and then figure out where that switchover is for the system. And I think after I finish, the next two speakers will really kind of go through some of their analysis of where they've seen this and how well this works. So, so with that, hopefully that was just a brief overview for everyone to understand what the technology is, and hopefully that we will be seeing a lot more of this in the future in these climate zones. And then hopefully Jason and Deanna can give a little more clarity on how efficient it is.
Hey, thanks so much, Chad, and stick around and we'll catch you on the Q&A session. So Diana, I'll have you come in and speak briefly on some of the studies you have from Slipstream. So take it away.
All right, just getting the screen share up now. And thank you, Chad, for the introduction. I saw a couple of Slipstream documents on your screen. So I'm really excited to talk to you today about our monitoring study that was conducted on dual fuel air source heat pumps in the 2019 program year. We did find that we were delivering comfort and savings to Michiganders. And I just want to check, can everybody hear me and see my screen?
Yes, yeah, we'll let you know if we can. So thanks.
Great. All right. So we chose to monitor dual fuel heat pumps for a variety of reasons, mostly to characterize the energy consumption and operation costs for both the backup fossil fuel and the electric consumed by the air source heat pump while it was operating for heating and even in the defrost cycle. We found that there was a need to monitor market installed dual fuel heat pumps. There was another great study conducted on cold climate heat pumps prior to Slipstream conducting ours. But in that study by Minnesota CEE, those researchers actually directed the sizing and installation of the heat pumps to ensure that they operate in cold climates. What we wanted to know is how the current contractor market is sizing and selecting both the standard air source heat pump that's been on the market for decades and the newer variable inverter driven heat pumps. And we use this information actually to inform our incentive levels in energy efficiency programs that we ran in the state of Michigan, as well as consumer marketing materials. So that really nice colored dual fuel heat pump image that Chad showed earlier was created for one of our customer handouts to help our customers understand how a dual fuel heat pump or a central air source heat pump would work in their home. And I just want to let everybody know that in the context of this study, dual fuel or our backup fuel is going to be delivered propane. So when it comes to the emission savings will look a little low, but note if you were going to be switching out, say, a natural gas customer, their emissions reduction is going to be significantly greater because of the greenhouse gas emissions that are generated by natural gas compared to propane. So let's take a quick look here at heat pump performance across the state of Michigan. As I mentioned, heat pumps have actually been used for decades right here in the state of Michigan, mostly by consumers that have propane, oil, and wood heat. But now with the addition of that inverter-driven cold climate heat pump technology from Mitsubishi's and on others, in terms of the ductless mini split line, our electric baseboard, and customers with electric ceiling heat, they're finding great opportunities as well. But we wanted to focus on the unitary centrally ducted market because Michigan has a large proportion of our homes heated with centrally ducted furnaces and air conditioners. So we looked at climate zones 5 and 6, which run across the Lower Peninsula. And we studied 8 centrally ducted unitary heat pumps. 3 were in new construction homes, so sites 3, 7, and 8, brand new homes that had ductwork designed for heat pumps. And then we had 5 existing homes that had a construction date as early as 1860. So really showcasing Michigan's century plus old farmhouses and a new home up to 2004. So across that, we had 4 variable capacity heat pumps. These are going to be the inverter driven heat pumps that are capable of modulating to a variety of different capacities. And we had 4 limited stage or single stage heat pumps that would be kind of entry level or mid-tier heat pumps that have been on the market for quite a while. When it comes to our existing homes, all of the ductwork modification was just limited to what was accessible in the basement to reduce static pressure issues. We had some supply plenum size increases and some return increases. In terms of our lockout temperatures, some systems had no lockout temperature at all, which meant that the user interface, as some manufacturers like to call it, or the thermostat, actually utilized some algorithms to determine the best lockout temperature. And other lockout temperatures or switchover temperatures, that's when we go from using the heat pump to the backup fuel, which in this case was propane. Those were set as high, in some cases as 30 degrees. So let's take a look at some of the results. What I have here is all the heat pump details. Hopefully you can see some of those pretty well on your screen. But Site 4 was kind of one of my favorite systems to study. It's top of the line Bryant heat pump. It is a variable speed system with a communicating control. And the thing about this communicating control was it allowed the customer to program their current electric price and their current propane price. And along with sensors across the system in the indoor units and the outdoor units, monitoring temperatures all over the place, it decides when to run the heat pump versus when to run that backup furnace. And because of that communicating control and the way the contractor sized it, which they sized it a little bit closer to the heating load than the cooling load of the home, they were able to achieve a 67% site energy reduction. That means that the customer's goal was achieved. They wanted to go down to 1 propane tank fill up a year, and they were able to do that without issue with their system. I've also got Site 8 highlighted, though. This was a new construction home. They chose only to go with an entry-level air source heat pump, and that was on the suggestion of their builder, who noticed that they were going to have propane, and they said, well, you really should go with an air source heat pump to reduce the number of fill-ups. They sized that for the cooling load because it's a single stage system, so they didn't want to penalize the customer's dehumidification or cooling performance. They were able to reduce their site energy consumption by 63% with a 25-degree lockout temperature. So it doesn't necessarily mean it has to be in order to get significant site energy savings. It doesn't necessarily have to be the top of the line heat pump, but there are some expectations we need to set with our customers to ensure that they do get the savings and the comfort that they want. So let's take a look at what the details of the lockout entail. So as Chad mentioned, fraction of heating hours above lockout or switchover temperature are extremely important, but as well as how long the heat pump is going to operate. Customers' comfort, their motivations, and their wants should drive the heating and cooling options that we're proposing. So if any customer is interested in energy savings, increasing comfort, improving their carbon footprint, those are really good indicators of suggesting a form of heat pump in your estimates. But if there's a comfort complaint, the one thing we should really be doing is checking the furnace and AC size, looking at the ductwork and insulation levels across the home thoroughly, and even considering blower door tests, because it may not necessarily be the size of the furnace or the air conditioner. In many cases, they're actually oversized. So if we thoroughly inspect the building envelope and consider some weatherization improvements, we may really truly be able to reduce fossil fuel reduction by 50% or more with either a single or a variable speed air source heat pump. But the key is to truly explain operation to the customer in advance. So that way they can see the value in a dual fuel system, as long as the heat pump is selected to meet their needs. So as a quick reminder here, I wanted to compare outdoor design conditions to fraction of hours above the lockout temperature. So in Grand Rapids, Michigan, our outdoor design condition is 6 degrees Fahrenheit. But you can see, according to the fraction of heating hours above the lockout temperature, again, that is our lowest, that's our extreme temperature. So we don't really want to size our heating system, for that extreme. We want it to run and keep us comfortable the vast majority of the time. So if we have an air source heat pump that's capable of providing capacity down to 10 degrees Fahrenheit in Grand Rapids, Michigan, like Brent's experienced, you can see that we can get 97% of our heating covered by our heat pump. So there is a little bit of a difference between variable capacity and single stage air source heat pump. So in our study, we actually monitored the the consumption of the propane and all of the electricity, and then we were able to model the coefficient of performance and determine where the lockout should be set in terms of coming to a cost equivalent COP. So what we found is that with the variable capacity systems, if there's a solid line intersecting the cost equivalent COP line, that means we should be setting a lockout temperature where it intersects the line. So site 1 had a lockout temperature of 20 degrees, could have done with a slightly higher lockout of 22 degrees, but that's not going to have a significant impact on the electric bill. But we can look at site 2 that had a lockout of 25 degrees, but we could see a little bit more savings in performance from that heat pump down to as low as 20 degrees. I want to point out site 4. This is that high performing system that we just looked at that had an unrestricted lockout. We could actually set a lockout temperature of 5 degrees on that so that the customer wouldn't experience excessive defrost cycles. Basically, the takeaway here is that when we're looking at those variable capacity or inverter driven modulating heat pumps, when they are sized closer to the heating load rather than the cooling load, we can get them down to a 5 degree Fahrenheit switchover temperature. And when we're sizing those variable capacity heat pumps around the cooling load, because there is some concern from contractors that variable capacity systems sized for heating don't perform as well in cooling mode, you would set the lockout temperature at approximately 20 degrees Fahrenheit. But what we can say definitively from this monitoring study is that customers with the variable capacity system sized closer to the heating load did not have any summer dehumidification or comfort complaints. They were very happy of the performance in cooling mode as well. So let's take a quick look at the fixed capacity systems. Here you can see, again, we did have another single stage system operating below 5 degrees. That unrestricted lockout should be set to 5 degrees. Site 6, that was another Bryant system with the evolution communicating control. And so the lockout temperature was actually perfectly set at the cost equivalent COP. And that is actually going to be a function of the thermostat and the ability to program your electric and your propane rate. So it really determines that optimal lockout temperature or switchover temperature for you. And then I want to point out site 8, they actually came into our study with a slight concern about a high bill complaint. And what we found that their heat pump was sized appropriately, and the lockout temperature was set pretty appropriately as well. But their high bill issue was driven by utilizing a constant fan setting that cost them upwards of $200 a year extra that they didn't need. So some of our takeaways for the fixed capacity systems are that air source heat pumps that are sized closer to the heating load can operate as low as 5 degrees Fahrenheit. The one important thing that runs across all of these homes is that they set their thermostat and they forget it. So they keep their home in the winter months constantly at 70 degrees, and in the summer months constantly between like 75. We have one occupant that does like it a little warmer, so their home goes up to as much as 80 degrees in the summertime, but their dehumidification is superior, so they feel really comfortable. And again, just a reminder that we want to let the customers know that there's going to be a longer operation and runtime with the fixed capacity systems, and the supply air may feel a little bit cooler. And again, with these fixed capacity systems, we're actually seeing a lockout of about 25 degrees Fahrenheit. So what Chad presented from the manufacturers earlier is true. We want to see lockout temperatures around 25. I think the manufacturers really are being a little bit conservative when they're saying 40 degrees. Michiganders in the study chose heat pumps for a variety of reasons, mostly to reduce their electricity use. They wanted to replace inefficient air conditioners and ground source heat pumps. They wanted energy independence. They didn't want that propane or oil truck coming multiple times throughout the winter. Many of them definitely wanted to reduce the labor that they would spend prepping and storing their wood. And of course, summertime comfort is really important. Everybody wanted a permanent cooling solution. They didn't want to deal with window air conditioners, and they wanted to have great dehumidification, which we need sometimes all the way through September and even into early October. And of course, everybody in this program was really sustainability driven. Both new homes and existing homes, the customers wanted adaptability and climate resilience from their HVAC systems. But some customers in Michigan do face pushback when it comes to requesting heat pumps from the sustainability aspect. So I just encourage everybody to look at the products on the market and look at those manufacturer rating tables to truly see how low these heat pumps can operate and keep everybody comfortable. So with that, I'll turn it over to Jason.
Thanks, Dan. And yeah, Jason, real excited to have you back way long ago. I used to set up courses and introduce you on many different green building topics. So it's good to see you there again and to be able to also introduce you and set up a session that you're a part of. So Jason, the floor, Gas Technology Institute, welcome.
Yeah, thank you, Brett. I remember going back to your internship days with the predecessor organization. So good times. I think first, I guess, Chad and Diana, I think you guys have done awesome work at laying the groundwork on sort of describing some of the things about hybrid systems that we should all keep in mind. And I think what I'm going to try to focus on is a little bit more about sort of expanding the capabilities and maybe vision of where things might go a little bit in the future. A little bit about GTI. Used to be the Gas Technology Institute. Now we're called GTI Energy, kind of rebranded, because a lot of the work that we do is not necessarily tied to a fuel source. It's kind of independent. So let's see if I can advance the screen here. Here we go. Okay. We have a lot of R&D. So it's like Slipstream, a 501c3 nonprofit group that does a lot of R&D, both in the lab as well as my work is involved with field work across the energy and buildings spectrum. So everything, one of the focus of today, I'll be talking about hybrid systems, but we're interested in decarbonizing and removing fossils from fuels, basically. So I think that's in alignment with everybody's, all the other folks here. And so the idea here is, you heard, I think both both Chad and Diana talk about this lockout temperature or crossover temperature or switchover temperature. As you can see, we're still kind of trying to figure out the jargon a little bit in the industry. But it's that point at which the system will move from one source of energy generation to another. And it's a really important concept. And Diana just walked through some really good details and some field studies of showing what was best on an efficiency basis. And one of the things that's interesting is that you can actually look at that temperature switchover point through different lenses of decision making. And so that's what I sort of want to talk about a little bit here. As a little bit of background, we do a lot of work with the Electric Power Research Institute. In fact, we have a whole decarbonization initiative together with them. And their recent National Electrification Assessment shows that they see a lot of consumption increasing as we have more EVs and electrification of many building end uses, et cetera. And there's concerns about where some of that generation is going to be made up from. I think Brett sort of touched on this in the beginning part too. And something to just keep in mind is that if you don't have on-site renewables, if you fully electrify, you could actually be increasing indirectly natural gas consumption that's being used at the generation plant to help make up some of the marginal emissions that might be made. So I think that's something to keep in mind and relevant to this conversation of hybrid systems, which can maybe choose which fuel source is being used. So we've done a lot of testing on some various equipment in the labs. You don't see the manufacturers here, but the best capacity and best efficient equipment is actually one of our sponsors on this call here. So there's some really good work in technology development being done by many of the manufacturers to increasingly improve the air source heat pump technology and the ability to perform in cold climates, which has really been sort of the holdback for wider adoption of these systems. And this has been borne out by studies like Diana just walked through, as well as some of the ones that others have performed with field tests, lab testing, et cetera, of air source heat pump systems. And so that sort of sets up a little bit of the context. And if we're looking at the broader electrical grid improvements that are being made and needed as we bring on more renewable generation, some people do have concerns about various issues around grid reliability, ability to manage peak scenarios, et cetera. So what you're seeing on this slide is a representative building. This was actually done in New York, Climate Zone 5, upstate New York. Looking at how that building on an hourly basis throughout the year would pull, what the electrical pull would be from using a electric heat pump system versus a furnace and a hybrid system. And the whole point of showing this is that the hybrid system actually provides a little bit more bandwidth and capacity on the grid because you can shave off those at those really extreme temperatures running with some kind of fuel, whether propane or natural gas, can actually help reduce that amount of winter peaking that might be needed. And so this plays into the whole concept you may have heard of, certainly a big initiative at the Department of Energy and with researchers like Slipstream is really involved with this, grid interactive efficient buildings, looking at how these systems can be deployed and leveraged without overtaxing the electrical grid and creating other reliability issues there. So that's sort of another part of the context here that I think helps. So in terms of emissions, I know there were some questions that came through on the greenhouse gas emissions impact of hybrid systems. And this is just an example from where I am in Illinois, just what the emissions look like using the Illinois grid mix versus using a natural gas burning system at various temperatures, and how that might be different and inform where you would want to have a switchover point if you were driven to make that decision based on the carbon emissions impact of the equipment, right? Because you can look at the impact either being economically focused on what's the cheapest cost to operate. You could look at things from an energy efficient or what's the best COP that I can get out of my equipment. And you can also look at things from an emissions perspective as well. And I guess sort of a fourth lens that some may be interested in. And I've had some consulting clients do this on new construction, is a resilience perspective, and being able to have like a propane backup for if needed with an electric air source heat pump for those homes that are concerned about reliability of the grid, and having some on-site storage through a battery coupled with the ability to pull in that propane or natural gas for backup. So if you're looking at things from an economic perspective, this table actually comes from the Minnesota Air Source Heat Pump Collaborative, which I think CEE and maybe, I don't know if Slipstream was involved with this or not, but great work being done up in Minnesota to help educate the market on deploying heat pumps, basically cold climate heat pumps. And they put together this great grid that sort of shows out based on where your electric rates are and where your gas rates are, what might be an optimal crossover point or switchover point. And again, this is focused on a cost basis. So on a cost basis, it's probably going to be a little bit higher. And you see, like in Illinois, where I am, using my rates for my January bills, if I had a hybrid system, I would be setting it at 45 if economics were my main priority. I know there's a lot of people here from Michigan, so I pulled up that as well. If you look at Michigan's got a higher electrical rate generally. This is from the EIA data, and a little bit lower natural gas costs. And so the crossover point with that higher electricity rate could be even higher. But that doesn't necessarily mean it's the most efficient use of a given fuel, right? So while if you're concerned about overall energy efficiency, you can certainly go down into the below 10 with the capacity of many of the equipment and the newer equipment like the IntelliHeat system. Getting down lower is certainly achievable. And somebody was asking, I know there were some questions about time of use rate implications as well and how that might play into things. And this is really where we're going to see some evolution with grid interactive buildings. And we're working with one, it's sort of a third-party controller, essentially, of these systems that can decide which fuel source to use and run the heat pump or the combustion equipment based on real-time information from electric utility pricing. Or a lot of times, if you're on a time of use rate, they'll give you day-ahead pricing, like a rate forecast, and you can use that or the system. Basically, has a level of artificial intelligence that helps determine if you say that you're economically driven and motivated, then it will help figure out based on this rate forecast when to use which system, whether it's on peak or off peak and what the rates are, et cetera. So some really interesting technologies being developed to help control and deliver things affordably. And that platform also can look at the same thing with greenhouse gas emission rates. There are real-time greenhouse gas emission rates from your local generation subregion of the grid. And there are tools that are publishing that data into a cloud right now. And so a matter of having a smarter thermostat be able to read that data of real-time grid emissions and then choose, is it more efficient to use emissions that are being fueled by natural gas at a generation source, or more efficient to use the natural gas in the building itself, sort of deciding which system to use based on those generation rates. And that's sort of what this diagram is conceptually showing. And it might be, this is Earth Month. Maybe you want to be more, have a lower CO2 footprint and slide the prioritization more towards the environmental side of the scale. Or maybe, you've got a sudden big expense like your water heater broke and you got to plan for or make up for that. So maybe you need to, 1 month, you need to be more on the economically driven approach. And that decision criteria can change where your switchover or crossover temperature point is for these hybrid systems. So this is some of the stuff that's starting to emerge, and there's technologies being developed by providers out there. It's worth noting that, a product like the Mitsubishi IntelliHeat is really nice because it's designed, a lot of the hybrid systems are put out as package systems where it's both the furnace and the heat pump together from one manufacturer. And what I really like about like what Chad was discussing with the IntelliHeat is that it's kind of like a bring your own furnace approach of working with existing equipment, maybe probably extending the service life of that equipment because you're running it less. It's getting less operating hours with the heat pump taking over some of that heating load, especially at shoulder seasons like this time of year. And really can help dramatically impact the market more than people that are looking to do a full replacement of their HVAC system. It's so important to make sure that the envelope work is done first to bring down the loads before to really maximize the impact of those air source heat pumps. And so if someone's system fails, hybrid system might be an approach to start them down that path. And then as they improve their envelope later, maybe through a retrofit of some kind or weatherization, maybe that set point can be changed then too. So a lot of flexibility options with many of the dual fuel systems. So I think that's pretty much it. And yeah, Brett, I'll turn it back to you.
Hey, thanks so much, Jason. Yeah, we are going to get into some of these questions that are coming in right now. There are a lot of questions, and so we're going to try to get to as many as we can. Before we do, just real quick, for those of you watching the recording of this, so not right now, but in the future, make sure to head over to our Thinkific channel or the GBCI channel or whatever channel you might be watching this on in the future, and take that quiz, get an 80% passing rate, and you will get your continuing education. For those of you here right now, live with us today, again, just a reminder, certs at gutenbergcerts.com. Check your spam. That's probably where it's going. And mark them as safe, though. You'll get your certificate here, hopefully in the next couple of days, and you will be approved. So for those of you who have been here the entire time, again, you're approved for your continuing ed. You just have to make sure you meet at least 50 minutes of the session. You're good to go, but we want to encourage you all to stick around, keep talking, keep having conversation. We want to get to some of your questions here. There's some fantastic questions and dialogue that I think we're going to have. So even if you're CEU approved, please stay. Let's keep talking and have a conversation. And before we get to those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Renya, all of our speakers, so many speakers. It's National Volunteer Month. And so we're super thankful for all of our volunteer speakers and our speakers here today and everyone who allow us to do what we do and get education out. And especially to our top tier sponsors who are helping us decarbonize, make our homes healthy, meet LEED, meet Green Star, meet Net Zero certification. That's Mitsubishi Electric, that's Rheem, that's April Air, healthy air quality, that's Panasonic, Aware now for smart technology to monitor air quality within our homes. All of our sponsors who allow us to keep these sessions going. So a lot of questions coming in, and Chad, I'm going to try to maybe start when I direct questions for the most part first with you, and then open it up to Jason and Diana, who can take a next crack at it. But Chad, when you spoke, I kind of started to get a feeling, and that these systems, or maybe the systems you're talking about, could only work with mini split systems and not existing gas furnaces. And I think a few other comments that were coming in, some people were thinking that too. And then I think Jason kind of tried to make sure that that wasn't the case. But could you just speak to how we can use our existing gas furnaces that we have? And I really like, Jason, how you talked about extending the life. I don't know, Chad, if you have, or maybe Jason or Diana, just if there's data on that too, like, getting more life out of the system before, we have to switch over to heat pump. And then follow up that question with one great question that came in, like, what if my future is to decommission the gas system, to shut down the gas line? Can this help me into that future? So Chad, big question, but I'll hand it to you. Yeah. What do we do with our existing systems?
Yeah, so that's a great question. And yeah, so the idea is that these can be used with existing furnaces. It does not have to be used we don't produce a furnace. So the idea is to use the existing furnace. And it's a great question. We know we cannot go all electric tomorrow. We cannot move to all electric vehicles tomorrow. And so while we have a working furnace in the house, it certainly is a good idea, especially if it's only a couple of years old or 5 years old or 8 years old, to keep it in place because we know the grid, it can rapidly change. We've seen monumental changes in our grid in the history of the United States very quickly, but it's not going to happen in 5 years. So the idea is certainly to be able, that's why we designed it so they could be used with pretty much any manufacturer of furnace and still have the benefits of the high performance heat pump and a really high performance air conditioner.
Thanks, Chad. And Jason, Diane, I don't know if you wanted to add to that a little bit or not.
Yeah, and the question of extending the longevity, this is a relatively newer area. And frankly, that research needs to be done. I think Diana could probably speak for both of us. We'd love to be involved with a project doing field testing of, let's say, the Mitsubishi system to see what kind of impact that has on extending equipment life, things of that nature. So yeah, it's an important question.
Yeah. Well, great. Thanks. So, some of the questions coming in here about greenhouse gas reduction and, obviously there's concerns about installing new systems, new gas systems, which lock people into some of these emissions. And so again, we just spoke to that. This is also for existing furnaces, certainly can do a new gas system if you're doing it. I guess my question to you, Chad, on new systems, would they need to be variable? Can they still be 2-stage or single stage for these systems to work? I assume they can be single because you can work with those older systems. But can you just talk about what some of the best, if you are dead set on using an existing or a brand new gas system, what is kind of the best, not brand, but what is the features of that system you should be installing with it?
So yeah, if I was to build a house, if I was going new and wanted to go with a new system in a cold climate, I would pick the smallest furnace that I could find and utilize more heat pump capacity. And if I had to, and why I say that is leads back to your first question, where one of the questions was, can I move to that decarbonization model later in the future? And you could. If you decide to use this very small furnace and then use a more, let's just say that you have a very small furnace and a larger heat pump and you want to move that direction, most of your heating has already taken place, is happening with your heat pump. Now, it would be challenging to say if you want to go all electric because the grid is completely renewable and we can use as much electricity as possible. Let's just say that actually happens one day. Well, then you would just go to electric heat strips. Now, I know that sounds like freaking crazy to most of us in the energy efficiency world, but when you are in some areas, we've had projects where we have solar and plenty of extra production. They have used heat strips in cold climates as their backup. And so they've used their heat pump, they use their renewable energy, and they use their heat strips to actually make up that difference of the small amount that was produced by would have been a gas furnace. So if you are in a climate zone, it's really best to, if you can use a high performance furnace and then use ours as well. So again, this is really where doing some training and having good contractors and consultants, and especially Jason and Deanna and the work that they do is really going to help us to best understand this journey moving forward, because it's not that it's going to be a moving target. Once we see how well we can put renewable energy into place and have smarter grids, that we can then make that adjustment to the types of movement away from gas. And again, we all know, most of us in this industry want to move away from it at some point. We are all trying to do it best for the consumer. Again, for the U.S. energy production model or grid, we've got to make sure of that. So I know it's kind of a long question, but there are multiple options. And I would say that's best probably answered by, we have lots of our salespeople in the field that can help our contractors to make some of those decisions, as well as some of the other manufacturers listed there too. They have, my team that is around the United States focuses on high performance and high performance building. So we certainly can tie you in. I'm sure Jason and Deanna have consultants as well that could help on that question.
Yeah, and Diana, I don't know, you presented a pretty good layout there of sort of the types of systems from the propane standpoint. Anything else you wanted to add to that, just from like a new construction side?
Yeah, from the new construction side of things, I'd just say that, when you're building new construction, the loads of these homes are significantly lower than that of a lot of the gas furnaces currently on the market. So in terms of customer comfort, you are going to see better comfort coming from the air source heat pumps. In those cases, of course, I strongly encourage the variable capacity air source heat pump just for the best economics and energy savings. But in a new home, operation cost should be very similar to that of a naturally gas heated home.
Thanks. Jason, anything to add on the types of furnaces folks should be utilizing?
I agree. Smallest, like Chad said, smallest is available. If you want to have that, I guess for some people, peace of mind. Mm-hmm. In new construction, I think we can design them out in a lot of cases.
Yeah.
So I guess the other thing to keep in mind, though, too, is the interaction. If we are doing a lot of heat pump systems, the interaction between space heating and water heating, mm-hmm. Especially in cold climates, you're basically going to be taking some of those BTUs that you've electrically heated with the air source heat pump, and then use that to then, through a heat pump water heater, heat your hot water. And there's some negative, interactive effects there that could be possible.
Mm-hmm. Yeah. What about on the multi-family housing side here, and how that could play in? And we sent some information out, and I'll drop it in the chat and share it with everybody too. But one of our founding organizations, Bazzani Construction, they built some what we call right-sized housing multifamily units up here in Grand Rapids, where it gets cold, for those of you who don't know. Climate Zone 5, all Mitsubishi ductless mini splits. To some extent, electric bills over the course of this cold winter were lower in some units than others. And so no gas backup, no resistant backup that I know of. But, for folks who are concerned, how could these systems work both in new or existing multifamily, or does this make sense in multifamily? So Chad, I'll kind of hand it to you on that one.
Yeah, it definitely does. And I think that this is where we're seeing a lot of progress when we're thinking about affordable housing and trying to develop the right model for housing that people, like you said earlier when you introduced everyone, it's really critical that we are building housing that people can afford. And a big part of that is afford to heat and cool. And so, we look at some of the models done, and Pennsylvania has a really good record of building some of their federal income low tax credit projects to the Passive House standard. And they saw a minimal increase in the amount to build those Passive House projects. But, and I mean minimal, like 5 to 10% increase. But you think about it, that's almost no power bill in a Passive House. And even in the climates of, Chicago and everywhere around, that's the type of thing we're seeing. So if you've got a project that was oriented properly to the sun, you've got great insulation, great air sealing, it is very minimal to heat and cool that. So they are definitely, small capacity variable speed heat pumps are excellent for multifamily. I think they're probably, in my opinion, would be the best because they have such small capacities if needed, and they can ramp down to even the smallest capacity for some of these apartments and small bedroom living spaces.
Jason, Diane, anything to add on the multifamily front?
I'll just add that the addition of ventilation on these new construction, remember too, and that has to be brought in typically through a separate system. Now, some of the hybrid systems can be worked in multifamily. In fact, one of the reasons I work at GTI is I used to rep a hybrid system from called Detson, which makes a very small furnace. And we were putting those in multifamily buildings to help the really reduced loads, and then provide in those, a lot of those units, dedicated ERVs in each unit. Definitely not affordable housing with that type of setup. It's more expensive, but I guess the short answer is, yeah, it can work in multifamily. There was a question about magic packs there too. I don't know of anybody that has something in that form factor yet. I think a lot of the multifamily are just moving away from that towards more of a, like Chad was describing, more of a VRF based space conditioning layout.
Yeah. And Diane, I know you all studied and looked at single family and a lot, but any comments there on the multifamily side?
Just on the multifamily side, that there is a large use now going towards the VRF style systems.
Yeah.
But we've also seen interest in geothermal for multifamily because of the larger capacities available. So heat pumps of any type.
I'm glad you brought up geothermal, because I wanted you to briefly give you a chance here to maybe correct something or elaborate. The question was, I think you had stated something about adding in air source heat pump systems because of issues with geothermal. Could you elaborate on that?
Thank you for giving me the opportunity to clarify that. I certainly want to keep the Geothermal Association in Michigan happy, because they are a great partner for Slipstream as well. What I was talking about in that context was a much older geothermal system, a 20-year-old open loop ground source heat pump. The customer's desire was to stop using well water because his area is actually experiencing a bit of a water shortage. So he wanted to be really neighborly, make sure he wasn't consuming groundwater unnecessarily. So to get a lower cost system without having to put in a ground loop, he opted for an air source heat pump system. That's not to say the ground source heat pump systems on the market today, they are exceptionally efficient. And I certainly encourage people to look in those, especially for larger homes with a bit bigger load. Ground source heat pumps do have the capacity to meet that. So please, I am not against ground source heat pumps today. It's just existing systems that might be aging out and in need of replacement.
Yeah, and for those of you who don't know, there's a pretty cool technology made right here in Michigan that integrates ground source heat pumps through wells into propane as a dual fuel solution here too. So we hope to have them on the show. They're super busy, won't even return my call. So, hey, it's a good thing, I guess. So, but anyway, let's get into static pressure for all of you HVAC nerds out there. We don't want to blow up these existing systems or, as we talked about extending their life, but what if we put something like this in and it harms the static pressure? And so basically, what that is, systems that aren't designed correctly from even going into the ducts, right? Ducting system, which is not something we're talking about here right now. If there's improper pressure, it'll wear on the life of the system. It'll be inefficient. We know that when we want to go for higher MERV ratings, we know, like 13, it starts to eat up viruses in the air. Very important these days, right? PM 2.5, all that wildfire smoke blowing over to all of us. It's coming any minute now, sadly. But anyway, we can ruin our systems. So Chad, maybe talk about what we have to think about with static pressure when we do like retrofit in something like this.
Yeah, it's a critical question. Not everyone on listening today may know how poor some of the systems are in the United States today. I think Train did a study maybe eight years ago that had like 96% of hotspots and cold spots due to improper duct design. And so with that, there's going to be a lot of problems. And if you do introduce any kind of variable in there, that could make an issue with how the air moves to the duct system and creates extra static. For us in this conversation, when we are taking out an air conditioning coil and putting in a heat pump coil, we shouldn't see a huge difference in that static pressure. It's a concern, but we shouldn't see a lot because the surface area should be fairly similar to what we are replacing when we put an 8 coil in. As far as the looking at contaminants and adding a better filtration, 100% agree that every house, unless it's very new and very well built, should have a very, very good filtration system. I don't really care where you live and outdoor conditions or indoor, you really need an upgraded filter. The little 1-inch pleats are not going to do it. We have too many contaminants in our house today and that we're all exposed to. And the one way around that is really to allow yourself to, or your HVAC installer to install a thicker filter. Even as something we've seen is 4 or 5 inches with no static pressure drop, and you can easily get into that 13 MERV range without compromising the system.
Thanks, Jason. Anything to add to that conversation there?
No, I mean, it's an important thing to keep in mind. I guess, we, a lot of times in the energy world, we focus on duct sealing and leakage issues and how that impacts static pressure. I guess it's worth noting that actually having retrofitting ducts is always it can be a challenge and actually increase static pressure if you're doing something like AeroSeal or something of that nature. So something else, just another thing to keep in mind.
By sealing the ducts up from the inside, you're saying you can actually increase static pressure issues.
Yeah, right. Because if you're doing that and then also doing,
or duct sealing in general, I assume, right? The mastics and
because right now those leaks are lost through the crevices, and so if you're up, then there's more resistance in the ductwork. And frankly, a lot of the ductwork design is not well thought out or planned in most residential construction.
Sure, it's not the fact that it's tight that's causing the issue. It's the poor design. You want it to be tight, right? So yeah. Oh yeah. Well, we could spend a whole nother 5 all-day training on duct leakage issues, and the thorn in my side that is. But anyway, I'll end that there, and we'll bring that up later. But so let's get back to these controls. Lots of questions there, lots of conversation there. Chad, do you see any opportunity for it sounds like our for controls, you sort of have the user could do it. Hey, it's 30 degrees outside, right? I'm going to turn my furnace on. That sounds awful. Nobody's sitting around doing that unless they're me. I operate my home like that. And that's a fun thing, right? I document it, but the average person is going to hate that. So then the other opportunity, it sounds like, is you have these, and there's not an agreed upon term, but lockout or whatever it might be at some kind of temperature. But is there something that's smarter? And I think, Jason, you were getting into that with carbon emissions and on the grid. So is there a smartness that's also looking at price, not just emissions or emissions? And then also when you look at carbon emissions, isn't that data that's being reported late? So aren't we already too late by then? You know what I'm saying? Like you get that data after it already happened. So Chad, maybe, I don't know if you have anything more to add to that with your systems, but think of what about these lockouts?
So you can change the switchover. That question came up, that could you later change the switchover if a variable changed? And you can. And for instance, I live in Virginia, and we have a lot of older farms that are now converting to large fields of solar. And so we have the option to purchase that for a couple kilowatt cents per kilowatt to buy all renewable energy. So in a sense now, before, since I don't have a solar array on our house yet, I'm like, well, I'm not sure if it makes sense for me to get an all electric car because I know most of Dominion is produced by fossil fuels. But now what we've seen here recently is we're seeing a big change in what we're allowed to have. So if I was in a situation where I had a dual fuel, and now I have the ability to purchase almost all of my electricity, which is renewable, I would change that. I would move mostly to my heat pump and use only a small amount of gas, just because that's how fast the grid has changed in the last couple of years, even in Virginia. So you do have that option. And I think that's where, again, when we look at, what the presenters talked about today, as far as analyzing that data, it's rapidly going to change. It's pretty amazing how fast we're building solar and wind farms. And in the Northeast, they have a very, very accelerated plan of wind production, especially offshore, so that their building code is, they're looking to go to net zero construction by 2030. That's all going to be predicated on having that renewable production, as well as on-site solar for new construction builds. And I'm not sure if he's still on, but there's a gentleman, that Rob Brennan, that we were working with to help put that plan together, building code. But it's really key to be flexible. I mean, that's what we really need to be. Is the great thing. That's a great question. I'm glad the person asked it, because if the grid changes like it has for me, it certainly can do the same thing in the states that you're covering. We have to be able to analyze the data and say, okay, right now we're getting a lot of this low cost wind power, and gas is at X kilowatts of production. Those type of variables should be able to change, and that's what I think that what Jason does is critical to understand. So we better put together the best solution.
Jason, anything more you want to add to some of the smart systems coming up? You got into the carbon emission side, but what about cost? So,
can you give me the screen share real quick, Brett? I want to show
Here you go.
Site to everybody. So
it's all yours.
Valuable here. So this is a site called Watt Time, which actually shows real-time emission rates for.
It's not sharing, Jason, and also your camera's off. I don't know, you disappeared, so.
Oh, okay. I guess I can't do everything at once.
Yeah, you're good. We can see it now, buddy.
Yeah.
All right. So yeah, you can see. So like here, I'm in Chicago, right? So you can see our grid. It looks a little bit cleaner right now than West, for example. But lots of wind in the Central Plains here. So out in Kansas, the grid there is looking best in the country at the moment. Right. So these are real-time data. In the way the electric markets work, there's a little bit of a forecast, knowing what weather is around the country, where things are, what they're going to be using to generate electricity. I think it's several hours out, if not a full day out. And that's how some of the electric utilities, if you're on a time of use plan, they kind of know what to expect. And so you'll get the day ahead forecast of what rates will be, but they can also look at that and what emission factor will be in the future as well.
Mm-hmm.
So,
yeah, thank you. I actually had just learned about Watt Time just yesterday, and was looking them up. And if you're out there, Watt Time, I'll be calling you, because we're hoping to do a session with you all as well. So, and time of use rates. So, there's been a lot of questions here and concerns about folks reaching out to their local heating and cooling contractors who just are completely clueless. And we see it to air source heat pumps, dual fuel systems, cold weather climate availability systems, not even knowing whole supply houses, just not having any idea. And I'm not going to name any names or throw anyone under the bus here. I'll just state it, so you know who you are. But so we had our big workforce development training a couple of weeks ago before spring break, or at least my spring break. And, we only sort of scratched at the surface, but we know students going into HVAC right now, people going into college, learning these trades, people getting re-educated on them, or just being aware, all the way to the person who's in the house with the homeowner making a decision, a conversation at the kitchen table. What do we do to get this information out? What can we do to help, and where are the ways that can be the most effective? And I'm sure we can't answer all that right now, but just Chad, what are your thoughts there? So.
Yeah, and we've had this a lot as well. We Mitsubishi as a company, we do a ton of training, and we have a lot of training facilities around the United States, whether there are our company-owned facilities or through our distribution. And it comes down to just continuously training, and we are trying to work in the why. That's something that's very close to me, of why contractors should understand why they're making these changes. And, if you just say, hey, it's the right thing to do, you'll say the environment, contractors could care less about that. That generally, it does not resonate with them, because it usually is attached to, oh, this is going to be a harder install. And I don't blame them for not doing that if they don't understand it, and certainly not promoting it. But if they do start to understand that we are not in the best position when it comes to climate, energy resilience, or independence, that we can make some very important changes to everyone if they start better understanding why we're trying to do this. And we're trying to integrate, and we have been for the last several years. My team does a lot of this within Mitsubishi, but we need all manufacturers to start understanding this. And I'll say, I have no problem saying it, a lot of these large manufacturers of HVAC do not want to move away from gas. That's just not their goal, because it's their cash cow. And I'm here to tell you that. And we're not one of them, because we don't sell anything gas, but they are resisting the transition from natural gas furnaces to electric heat pumps, because they don't have the technology. And I understand that. But what we need to do is continue this education path. And these other manufacturers are slowly but surely moving and developing their technology. And they should be catching up with what primarily has been Japanese manufacturing of heat pumps that can, effectively heat down to below -13 degrees in some cases. So, the education is critical from all sides, but certainly from the manufacturer side, so that we have our contractors understanding the why from the get-go, and then the how, and then the benefits to the consumer, and that they understand the why. So it's not something our distribution generally talks about, but that is why we are also training our distribution to understand the huge opportunity for them, so they can see it as a dollar return, a return on investment, to change their technology, to start promoting more of heat pump technology electrification, because it is coming, and it is coming with a big, amount of ROI for them if they invest in it now.
Yeah. Yeah. And, comment that came in here, just getting HVAC to make sure they're doing the proper sizing, right? Manual J, manual D, and on existing housing, getting those blower door numbers, because that'll help with that proper sizing. Really a lot of cool stuff coming out of our friend, Nate Adams, who's got the home comfort book. If you're looking for ways to spur your contractors to get trained and more education, it's a great place to look. And just starting with some of the basics of evaluating what's going on in the home, before you even get to the heat pump side. But that'll definitely come up later. Jason, any thoughts from GTI and just general contractor training opportunities? Anything you're seeing out there?
It's a challenge. I think it's, as much as we all want to push forward technologies, we have to remember this is a area of professionals that don't, in many cases, don't have the capacity or the time to continue to their own education. And like Chad was sort of saying, it's oftentimes what they know that's easiest and most convenient to do is done. This is going to be an increasing issue, I think, for all technologies that are being done along the decarbonization front. And it's really, it's a big issue. Trying to engage people. I think some of the things that can help with this are some of the tools that coming online that allow for fault detection and diagnostic, and kind of like predictive when equipment's going to fail, instead of having an emergency replacement. I think that's a huge issue. People will go with whatever's on the truck because they need heat. And if that's a 80% gas furnace, then that might be what goes in. If it's not many people are carrying air source heat pumps on the back of a truck. But if they know that their furnace is failing, then they can be more educated and be in a position to make an informed decision, and sort of lead the contractors along, kicking and screaming if need be.
Yeah. Great points on just, people are just trying to get the work done, and it's, tough to go through all education and training when you're just trying to spend every day doing installs, and especially right now with labor shortages and everything, there's a lot of challenges.
Yeah, and I don't mean to throw contractors in the bus. I love them. It's just to be clear, but I know there's labor shortages, there's supply chain issues. 32 weeks I heard for a coil yesterday. For coil, I mean, just there's a lot of strain on the industry, I think.
Yeah, no, it's all good points. So,
hey, Brett, one thing I'll say, and I what Jason said, we're not throwing the contractor under the bus because they are in this really hard position right now. They are, and this is why we talked about workforce development. They don't have the people to bring in, and a lot of manufacturers have not offered the type of training for them. So it's not really fair to always blame it on a contractor. They're hardworking private owners of businesses, and it's really tough to get educated and take that time to be better. It's manufacturers' jobs. I will tell you, it's really our job to be there and provide them, zero cost training, flexible training, so that they can train themselves and their teams to be able to answer the questions and be the best contractor for those consumers. So it's not, I don't blame it always on the contractor, and I rarely do because of what I just said, but it is just something we have to always, as manufacturers, improve on.
Yeah, good points. Thanks for clarifying on those two. So, we are at our time. There's been a lot of great conversation, a lot of great dialogue. We will send that out and give you all more opportunity to keep having those conversations. But in the meantime, and I'll start with you, Chad, where can people go to either contact you or learn more and go from there?
Sure. I can put my contact information for me and my team on the high performance side. And then we also have our utilities team who does a fantastic job that I know that you guys have worked with before. Any of us are available for different types of questions. And then if we have more specific questions where we need one of our contractors, we have 4,000 plus diamond contractors that are certified by us. And we certainly can put you in touch with the ones that we feel like who's taken that extra bit of training to understand more about high performance installs. So I'll put my contact in the chat, and again, you can reach out to me, and I'll pass that out. 9 team members around the United States, and then we have utilities team as well that can be of local help.
Thanks. And Jason, where can people go to learn more or contact you if they'd like?
It's not great at publishing all the information that we compile, but I'm happy to dialogue with anyone that has interest. My mail's up on the screen there. Feel free to reach out, and love to chat more.
Great. And Diana unfortunately had to go, but thanks to her email is there, dcacko@slipstreaminc.org. You can go to slipstreaminc.org and get access to all their studies. And we're going to have her back, I think, for a heat pump water heater study. So you'll get another chance to talk to her. Chad, Mitsubishi, Jason, GTI, Slipstream, Diana, thank you so much for your time and for educating us on this important topic. Really appreciate it. Thanks to all of you for joining. Take care and have a great rest of your week, everyone. Goodbye.
Thank you, Brett. See you guys.
Take care.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.